Hi everyone, my name is Mustafa Berkeleş and today we will talk about our software testing and validation project. It is Medical Case Share. Firstly, I want to explain what is Medical Case Share. Medical Case Share is an online case sharing platform for medical experts and researchers. In this part, we will examine the GitLab account of our project. As you can see here, we have 4 repositories. These are acceptance tests, backend, frontend, and stress tests. In the acceptance test, we have spec files and test.js file for acceptance test. In the backend side, we have the API. We have the code of API and or MVC structure. This is the key point of the project. In the front-end side, we have user interfaces. This repository mainly consists of JS files, JavaScript files, CSS and HTML files. In the stress test repository, we have some JS files related to load test. We apply a load test to our project. Let's look at the HerOKU account of our project. When we look at the list, we can see 4 different deployments. Why we have 4 different deployments? Let's see. In the first one, we have the front-end part, deployed front-end part of the project. This is the production environment. We are using it. And the second one, we have the API. We are giving the response to requests. This is the core point of our project. It is the deployment of the backend side. And these last 2 ones are the pre-production environments. These are the quality assurance environments. What it means? When something changes or some developments done in front-end side or back-end side, they are deployed to these 2 ones firstly. When this changes, when these developments are tested and they pass the test successfully, we are deploying them to real production environments. So we have 2 pre-production environment, pre-production deployment also. Here, in the backend side, we have controller, custom error, helper, mocks, model, structs, view, folders. Let's look at the controller side. We create everything in modular form, which means we put related things to related files. When we examine the controller folder, we have 5 Go file, as you can see. In the calculation controller, we put the all controller of the medical calculator to this file. Same thing was done for case controller, command controller, and user controller. Also, we create a test file for each part. For example, in the controller part, we have the controller test.go, which contain the unit tests for controller side. When we look at the view side, the same structure is seen. We have a view test file and we have related files like user view, command view, case view, conclusion views. In the struct part, we create the struct of our objects like like case, like comment, as you can see here, like case entity. And in the mock part, we have the mock files. One of my friends, Anil, will execute the all unit tests, and he will explain some of them for you.
Today I will run all of the our backend tests. First I will run okay, it will take 1 or 2 minutes. Okay. These commands run all of the tests, so it will take a time. Okay, you can see the all of the tests passed. First, our controller tests run, and after here is the end of the controller test, and our view test, unit test, start here and run, and all of the tests passed. Okay, I will explain some of them on our tests and our test process, how to test, how to do TDD. Okay, we are first start our actually scenario test BDD on backend side. For example, we look register, test register. We use Conway and default testing package on Go here. Conway is create the sentences and or test stages, something like that. We write given valid register data, and we create function. Inside the given part, we create the our application, our API, and after the when part, when register request sent with valid user data, we create the test valid user data here, and when we write these lines, we create a request, and we send the test data to request body, because this method type is post, and this line app.test we send the request here, and we take a response and error here, so error should be nil. If we have error, it throw a error. And Conway then part, then status code should be 201. Okay, when we write first and run the test, it failed, and first we go to our controller. For example, this is about the user. this user can register. So we go to user controller and create the endpoint, which is return 201. But it can register the user. We create the endpoint here, post method type endpoint, and we create the handler method. Okay, here, and create the function here, and we write the function according to this test. For example, take the request body valid register data and send the view register method. Inside the view part, when we come to view site, first we write the view test, which is unit test. We use default testing package, and actually we use go mock package. We mocked all of the view methods. For example, inside the register we have only one model function. It saved the user data to database, which is MongoDB Atlas. And we have client method actually. When the user data saved success, it will send the email to user for activation. Okay, we must, when we write the function, we must mock these two methods. First, we write this test before the implementation. We create the test data again. Actually, this is our register and this is our request body data transfer object, and create controller 1 and controller 2 here. Actually, these methods generated by mockgen, we generate from here. When we write when we run generate mocks here, it created mock files under the mocks folder here, and actually we can go to mock user model go, for example. He generated mock functions. When go back to view unit test, we create the model mock and client mock. Client mock is a email client. It's only has a one function which is send mail. It's only send a mail. Okay, again go back to unit test. Okay, we mocked model and client, and we create the view. It take the model mock inside here and create view, because we mocked the view, and we write the mock methods like this, because inside the user view register function we have only two function which is required to mock: register model and client. We mock these two function like this. For example, register model, we used this test data, and after the register model, it is success, it must send to mail to user. Register mail, send mail, register mail, user. End of the methods functions, we send to register DTO. Actually, our API took the data from front end, this type of data, register data transfer object. I think that's it for unit test, and actually our tests process the view site and continue the here. Okay, actually that's it. Thanks for listening.
In this part, we will talk about acceptance tests. As you can see here, we create an acceptance test repository, and we did web browser automated acceptance tests. You will understand what I mean in a few minutes. As I mentioned in the testing document, we have some spec files also, and also JavaScript files to turn them into running codes, running acceptance tests. In spec file, we are giving the steps of the uh, scenarios in a written format. Here we have a user story which is written in user story card format as I want, so that form. In the first one we have, as a researcher I want to register the website by entering a mail name, a username and university, so that I can download the cases and use them. We turn it to given that when then formats. Each line present this in this part, each line present a step which will be implemented in the which will be applied in the acceptance test of the scenario. Here we say, given that I'm on a I'm on a URL, I'm on a register page, and I select researcher as a user type. When I write a random for email, this is the ID of the field which will be filled. When I write James, this is the value for name. This is the ID of the field, name field. And there are more than statements here. Finally, we have then statement. I will see the success register message. This is the type of the showed message. We did it for each scenario. Let's examine this JavaScript file test file. Here we create some general steps. They can be applied in each acceptance test scenario. Why we did it? We thought the writing code is not suitable for a software project, professional software project. We need to write flexible code. We need to write professional code that can be applied in each situation, that can be change behavior uh, with given parameters, so that we create this step like a function. It get parameter like URL user type, and it use it inside of it. Here we have a common given that step. Here when we go to the spec file, you can see it in each scenario, in each when that's given that when then scenario. Look at this one. Look at this one. They are same. Only the parameter of them are changing. Also, we create some when steps. They are also general. They have values, IDs, parameters. We are getting them from the spec file. As you can see, this is the URL. This one is the URL. We are sending this one to here. Here. As you can see, this is the type of user. We are sending it to here. So we write less code but professional way by thinking how we generate a specific, not specific, general steps that can be applied in each acceptance test scenario. Here we have a headless property. If I give false, it will show each step in my browser. It will implement each step in my browser automatically. I will not click anything. I will not fill any fields. Only I will watch how it will implement or acceptance test, how it execute or acceptance test. Let's go to the comment line, comment prompt, and I will say I want to change my directory to my acceptance test repository. Let's change it. We change it, and I want to install my needed packages. Let's run it. It will install for us. It can take a little bit time, so I am stopping the record now. Now we will execute our acceptance tests in a automated web browser manner. We will see how they are executed in an automatic way. We will watch only the implementation implementation of this acceptance test. We will see how they are compiled, how they are executed in an automated web browser. I think this is a very useful technology. We use Tycho and Gauch for this purpose. We will do a web browser automated acceptance test now. After my packages and dependencies are installed, I'm writing npm run tests, and when I click it, a web browser will open it in the left part, and it will execute my acceptance test automatically. As you can see, I am waiting only, I watching only. They fill by itself, and they implement acceptance test by itself. They execute by itself. And at the title of this Chrome page, you can see a sentence. It says this panel is controlled by Chrome automated test software. There is no people who writing these ones. It is a browser only. It executes my acceptance test automatically. I am watching only. As you can see, my research registration acceptance test is passed successfully, and each P letter means The step which is written in the spec file is passed successfully. Now we are testing the email error acceptance test. If user try to log in, try to register with an existing mail, he or she will see an error message. In this way also we are seeing our project and how it's look like. As you can see, the register email error test is passed successfully too. And now we are testing the required fields. If user leave empty a field, we'll see an error message. As you can see, it say you should fill all fields. Now we are testing the login main success scenario. As you can see, we log in it successfully. This scenario is passed. This acceptance test is passed. And now we are trying to log in with a non-existing user. There is no user in the system like that, and we will see an error message. This is a negative scenario. This is an extension scenario. Now we are trying to log in, but our mail address and our password is doesn't match. Doesn't match. As you can see here, it doesn't match. And we see the error message successfully, and now we are trying to forget password. We are watching only. It's so enjoyable, I think. But time is late, so I get tired. Let's finish. Now we are trying to calculate a medical measurement by firstly we need to also log in. After that we will go to the calculator part and we will write the related information, related data. In this way also you can see the all functionalities and all pages of our software. We don't need to show you again. By watching the acceptance test you can see what our software do. You can learn everything from our acceptance test about our software, because it tested every scenarios and it tested every possible things. So you can see, you can learn everything from the this part about our software, how it execute, how it look like, how it responds to some things, what are the functionalities of it. You can see it. Now we are trying to get an error message by writing wrong input to calculator part. As you can see here, our creating calculator error acceptance test is running now, and we'll log in it firstly, and we'll go to the calculator page, so that then we will write wrong inputs, invalid inputs to the calculator part. We will fill all of them as a 0, and when we click it, it will show me the error message like the all field must be the numeric value or the greater than 0, and the same thing will be done for the mass index 2. It's running now. First we will log in it. May take a little bit time because there are many steps in each acceptance test scenario. And we will go to the BMI calculator, and we will fill all them as a 0, and we will see the error message. The next thing we will do the filtering operations. We will test. We will run the we will run the create case scenario. Here we are creating a case. right click to new cases, you will see the case, adding case page. And we added, as you can see, the acceptance scenario is passed. It added the post successfully. Now we will filter the case by name. In the first step, it's login. As you can see, the filter by this name is pass. This acceptance scenario is acceptance test is passed to. The last one is executing, I think now, and now we are trying to filter by age. Now we are searching with the age. And it's seen, as you can see, all tests are passed successfully, and we execute, we can see how much test is executed and how much of them is passed here. The 15 acceptance tests were executed and all of them are successfully passed, as you can see here. These are the executed ones.
Hi teacher, my name is Ufuk and I will explain the stress test and the pipelines on GitLab CI/CD. Firstly, I will start with the stress test. For stress test, we are using K6, which is help us to checking our stress test. Also, we can make another performance test with K6, but according to our definition. But in this test, we are making a stress test. We can start from the top, I guess. Firstly, we set our thresholds. Thresholds help us to define our priorities, which is, for example, we are checking our request should be uh, our request error percentage should be less than 1%. For example, also there is another threshold which helps us to define some limitations in our request. Uh, for example, we are checking our request durations. 95% of our requests should be below the 1 second. And in stress test, we are checking the 4 different endpoints, which is a get cases, calculate BMI, calculate Cockcroft, add comment endpoints. And in those scenarios, we are setting some options in our scenarios. For example, we set an executor which is saying we are starting with the constant virtual user number. There are some other executors which helps us to increasing our virtual users number as a linearly. But in this settings, we are setting as a constant, and we set those virtual user number in 25 right here. And this rate shows us to how many requests those virtual users sends on request to our services. We are setting those times in here in rate. In exec, we are setting our function name, which function should run in this get cases scenarios. And we set our request functions right here. For example, we set our URLs and other params, and after that we are sending our request, and we checking is it its status is response status is 200 or not. And also we are setting duration time, which is show us to how many seconds we will send a request to our service, how many seconds it will accept, or we are going to send a request to do our service. And graceful stop shows us to how many seconds after the duration it will stop. We are giving a 3 seconds for that. Actually, as a sum, we are sending a 3 second 20 second actually request. And as you can see, almost all of them, all of those are settings are same. But before the test runs, we use a setup function which helps us to create a case in that point, because when we trying to get case, we would like to create a new case for it, because actually not for get casing, we are created for the add comment, sorry for that, because we want to create a new case for it every time. Because when we delete our cases in QA environment, this endpoint will be blow up because we didn't create a generically a case for it. When we use that setup function, we are creating a case for that purpose, and we pass the case ID as a return variable, and we catch that data right here, and you put our ID inside of it. Also, I will run this test on pipeline. It will be better show the for thresholds and some other things. Okay, it started running. Okay, it's completed, as you can see. And as you can see, these logs show us to how many requests are we sending. For example, on 2 seconds, we are sending out 4 completed requests, and it's almost in 3 seconds we have completed the 8 different requests. As you can see, it shows us how many virtual user are we using on request. For example, at command, we are sending a 25 different virtual user. As a sum, we are sending 100 virtual user on our backend service. And as you can see, we are completing 72 different requests in a 18 second. And also these are the thresholds which I talk about it. For example, we have set our request duration 95% should be lower than 1 second. But as you can see, it's almost half of it. But we give a little bit more time for it. And as you remember, we set our request failed percentage. We are saying it should be lower than the 1%, but all of our requests completed. Because of that, it's at 0% right here. And also there are some other thresholds which we can set, but we set just 2 of it because it will be enough for us at this point. And I think I can show the other pipelines which is in our backend and frontend. I can open those. Okay then. In our backend, we have 6 different stage in our pipeline. In first stage, we are Dockerize our Golang project in GitLab, which is helps us to hold our image of our program. And after that, we are using an Kaneko, which is developed by GitLab, and it save our image inside of that container registry. It's directly hold here. And after that, we use that image to run our test, because in that image also we have our code files. And when we run our test with a script, we successfully passed our test. And after that, we take a build, because we want to check is there any problem with our code to taking a build. We don't want to face it with any environment, QA or prod, doesn't matter. Because of that, we are taking a build before deploying any environment. And after that, we are deploying our code to QA environment on HerOKU. And we are using a Ruby image for it. And we set our APK on HerOKU, and we give our project name. And after that, it deploys directly. And on that trigger stress test, after deploying our code to QA environment, we are triggering our stress test, because we would like to check is our logic working fine? I mean, is it fast or not, or we can improve our logic at that point. Actually, we are not running any code in this project. We are directly go to the stress test endpoint, stress test repository, sorry. And we trigger that endpoint, and it's running again, start to run. For example, there are some push which there are some pipelines runs which we pushed today. As you can see, it's triggered by the backend repository. And when it's triggered that stress test repository, it's directly start to run. And after that, if it's our stress test is correctly working according to our thresholds, we are deploying to prod site with our code. After that, I can move to the front end side. Also, I can show our pipelines. As you can see, those are the stages: package, test, build, deploy to QA HerOKU, trigger stress test, deploy to HerOKU, and this one is the stress test stage. As I said, this trigger stress test trigger that stage, and after that we are checking it's our stress test repositories start working. If it's okay, we are going to deploying our code to prod side. And in our front end side, we have 3 different stages at this point. We are first deploying our code to HerOKU QA environment. Again, we are using a Ruby image for it, and we give our APK right here, and after that we are setting our project name. And in our second stage, we are running our Taiko test. We firstly install some dependency apps. For example, there are lots of apps right here which help us to run Taiko on GitLab CI/CD. And after those dependencies installed, we are cloning our repository, acceptance test repository, and we get into that file and we install some other apps, and we starting to run our test. And if it's our acceptance test working correctly, after that we deploy to our production site on HerOKU. Again, we are using Ruby, and we give our APK and we set our production app name.